Welcome to Healthy Living, Healthy Planet Radio, sponsored by EarthX, the world's largest environmental experience, and also sponsored by Natural Awakenings magazine. Live your healthiest life on a healthier planet. Now here's your host, Bernice Butler.
Welcome to Healthy Living, Healthy Planet Radio today. We're now in our third season, and we remain just as excited as ever to continue to help you explore and understand the unbreakable relationship between your health and the health of the planet. Here we look at the hottest topics related to our environment and its sustainability and how they affect your health and wellness. Here, issues like climate change, plastic pollution, extreme weather events, and others will meet up with everyday impacts like allergies and asthma, digestive issues and gut health, cancers, lung and heart issues, and more. So listen in today as we interview experts for today's show on waste. And specifically, we're going to be looking at industrial waste and e-waste, the ever-proliferating, hidden in plain sight, yet not unnoticed by our health. For many businesses, the collection and disposal of industrial waste presents a host of challenges. The byproduct of industrial activities, which is what industrial waste is, ranging all the way from manufacturing to electronics and auto repair. Industrial waste can also include scrap metal, chemicals, universal waste, and a myriad of other potentially toxic compounds. Industrial waste are generated by everything, from brewing and winemaking all the way to a hospital visit. All of these are things that we like and that we need. And our increasing demand is increasing the problem. Industrial waste contamination can occur whenever toxic byproducts find their way into the environment without proper processing and disposal. When dumped into the oceans or landfills, hazardous materials can release toxins into the environment, thereby disrupting habitats and causing harm to wildlife and humans. The effects of improper disposal of industrial waste include immediate and long-term effects. And as they enter the human body through many pathways, including ingestion, inhalation, and skin contact, many are very detrimental in terms of the health effects, and these have been indicated and or documented in many cases. As a result of research studies aimed at identifying the hazard and assessing health effects posed by hazardous waste sites in the U.S., the Agency for Toxic Substances and Disease Registry has identified 7 groups of health effects most common among populations living in the vicinity of waste sites. And these go all the way from birth defects, cancers, to immune function disorders. Now, to be sure, the issue of its disposal may actually need to begin before it's ever generated. And there is a unequivocally consistent global consensus in minimizing such waste to decrease the burdens on almost every aspect of our environment, and the threats generated to our health, of course, are all around us. Now, a growing and persistent component of waste, and perhaps component of industrial waste that we're also going to dissect today, is e-waste. So a few questions to consider. Are you purchasing the latest cell phone every time a new one is released? And if you're like almost 50% of iPhone users, that answer is probably yes. And how many computers have you gone through in your lifetime? Probably quite a few, I'd say. And so I have to ask you, where are the old ones? And have you recently updated any of your large house appliances? Recent studies from the Global E-Waste Monitor in 2020 show people are buying new appliances more than ever. I think a little of that has something to do with the pandemic. And among the startling conclusions in their report is that our global e-waste is on track to reach 74 metric tons by the year 2030. And that represents nearly a 100% increase over the last 16-year period. And this makes e-waste the world's fastest growing domestic waste stream, they say, fueled mainly by higher consumption rates of electric and electronic equipment, by the short life cycles of this equipment, and by the minimally few options for repair. So the real question is, where do all those obsolete, outdated, or non-functioning electronics go? The answer is they become electronic waste, or e-waste, also known in some cases as e-scraps, and they've probably got some other names we don't know about. The EPA estimates that in 2009, U.S. consumers and businesses discarded televisions, computers, cell phones, and hard copy peripherals, and this is in the U.S. alone, including printers, scanners, and faxes, totaling 2.37 million tons. And approximately 25% of these electronics were collected for recycling, which is not very much, with the remainder disposed of primarily in landfills where those precious metals cannot even be recovered or reclaimed. And children exposed to e-waste are particularly vulnerable to the toxic chemicals they contain, and that's due to the children's smaller size, their less developed organs, and the rapid rate of growth and development. Children absorb more pollutants relative to their size, and they're less able to metabolize or otherwise eradicate those substances from their bodies. So, why are we generating more and more metric tons of e-waste than ever before? This is a lot, and hopefully our experts who are here with us today can help us understand this and unpack some of this a lot more. Here with us today to help us out, we have Jim Puckett. Jim is with the Basel Action Network, and we have Dr. Grishma Gadekota with Cornell University. Now, Jim is the co-founder and executive director of the Basel Action Network, and as an activist for over 25 years, his work on toxic waste and toxic waste trade has helped control pollution, safeguard fragile ecosystems from bioaccumulation of toxins. It's helped to protect the world's poor from health hazards, and it's helped to reuse the Earth's limited resources. Jim was the first to investigate and expose the export of electronic waste or e-waste. And then the Basel Action Network's 2002 film called Exporting Harm, the high-tech trashing of Asia, was the first to shine a spotlight on e-waste trade, and it transformed an unknown dumping practice into a well-recognized global issue. Jim has since overseen creation of the eStewards certification program, which certifies electronic recyclers. And prior to establishing the Basel Action Network, Jim was Toxics Director for Greenpeace International, and his regional campaigns were instrumental in generating public and government support for equitable trade policies throughout Europe. Jim, thank you so much. Did I get all that right?
Yeah, I think so.
Well, great. And then our next guest is Grishma Gadekota with Cornell University. Dr. Gadekota is an assistant professor and a Kroll Sesquicentennial Fellow in the School of Civil and Environmental Engineering at Cornell. Grishma directs the Sustainable Energy and Resource Recovery Group there. And prior to coming to Cornell, she served on the faculty at the University of Wisconsin at Madison, and she held postdoctoral research appointments at Princeton and Columbia University and at the National Institute of Standards and Technology. Grishma's PhD is in chemical engineering with a master's science degree in chemical engineering and operations research, and she is a recipient of the Department of Energy Career Award, the AICHE SABIC Award for Young Professionals from the Particle Technology Forum, and she's highly involved in many other aspects of her field. Welcome, Grishma. And did I get all of that right?
You did get it right, Bernice. Thank you so much.
Thank you all both so much for taking time to join us. And we just have 1 minute before we go to break. So I'm going to ask you a quick question, and I'm probably going to need to stop you almost in the middle of it, but we'll get back to you after the break. And I want to start this off with Grishma by telling us what industrial waste is and how it differs or intersects with e-waste.
So my perspective of industrial waste is that it encompasses gas, liquid, solid waste materials that are produced from producing high-value industrial products. So from my perspective, it encompasses everything that has very low value and is getting disposed of either in a landfill or is getting emitted into the atmosphere, is getting stored in a subsurface environment.
And I'm going to stop you here. We'll probably review that on the other side of the break, too, because you said it's in high-value industrial products, but it looks like it's generated in everything, like I said, even walking into the hospital and getting some services or producing a paper cup. We'll be back on the other side of the break to really get into this a lot more. And we are with Dr. Grishma Gadekota and with Jim Puckett from the Basel Action Network. Thank you so much. We'll be right back. I want to give a shout out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Magazine, the Green, Healthy, and Sustainable Living Authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in all Whole Foods markets, natural grocers, central markets, sunflower shops, and many, many other locations, as well as available free for download online at nadallas.com. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsor is Lynn Dental Care, practicing dentistry for over 38 years with a holistic approach, non-mercury, looking at the whole body. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsors. Welcome back to Healthy Living, Healthy Planet Radio, to today's show on industrial waste and e-waste, ever proliferating, hidden in plain sight, yet not unnoticed by our health. And we are back with Dr. Grishma Gadekota from Cornell University and Jim Puckett with the Basel Action Network. Now, before the break, Grishma was talking with us about what industrial waste means to her or how she's defining it. And continuing on from there, Grishma, could you talk to us a little bit about what is perhaps the most helpful or perhaps maybe the most memorable definition of industrial waste, maybe for ordinary people in their everyday lives, and why it's important to them or why they should know about it?
I would say the easiest way to think about electronic waste is that every time you go to the store to purchase something, to have paid money for it and to have gotten a product in return implies that you have paid for not just that product, but in the process of making that product, there were a lot of associated emissions. And those emissions could be in the form of gases, they could be in the form of liquids, they could be in the form of solids. That is really, for me, a very household, accessible way of thinking about industrial waste. It may not be a definition, but it's a very practical way of thinking about our relationship with the products we use.
Thank you for that. And I doubt that many people think of it in that way every time. And a lot of those times, increasingly online, it's even the e-waste that we're going to talk about as well. That's what I meant when I said it's all around us, hidden in plain sight, but not really hiding. I think maybe the sensitivity or the awareness of it is what's hidden. So it's prolific, to say the least. And so I think you mentioned some of them, but I want to go over the different types of industrial waste.
So one way to think about industrial waste can be in many forms, right? So it takes an enormous amount of iron and steel to make your car. Have you thought about all the emissions that are associated with it and what is done to put those emissions away? It takes an enormous amount of CO2 emissions to build a house, to make the materials. But we don't necessarily pay attention to that on a day-to-day basis. The only times we pay attention to our house is when it's really new or when it starts to break down, really. But we don't necessarily go into it with the mindset that in order to construct this house, there were quite a few emissions that were released into the environment. So those would be two examples, very concrete examples of thinking about industrial emissions.
Can you possibly imagine in your mind, far-fetched though it may be, a time in our society, we'd probably all be gone, when everything would have one of those tags like on the back of the food cans? Everything would have one of those tags attached to it showing the amount of industrial waste or emissions that went into this. That would be bizarre.
That would be great. That's real eco-labeling. You would know precisely what kind of waste to produce to make that thing you're buying on the shelf.
Indeed, indeed. And Jim, talk about or describe or define e-waste in the context of the whole industrial waste cycle or stream.
Yeah, so e-waste is a little different in that it's also your waste, your domestic waste, which is not usually considered part of industrial waste. So the waste we produce from our homes can be e-waste, but it also can be industrial. It also can be corporate waste for sure. And as you mentioned, it is the fastest growing waste stream on the planet from the proliferation of our use of electronics and their rapid obsolescence. So we're producing now over 50 million tons a year. And to get your head around that, that's about 1,000 laptops every second. So that's a lot in a year. A lot of seconds in a year, a lot of massive amounts of waste. And as you also mentioned, it's not just a big pile of litter. This is hazardous waste. And it's part of the problem is that the industry hasn't had enough incentive to realize that, wow, we shouldn't be putting so much toxicity into our products. We shouldn't be even making so much waste. So many of the answers lie upstream and not downstream. And once we get to the point of which trash can to throw it into, it's a little late. Indeed.
It's interesting, though, as we were thinking, as you all were talking, like when Grishma talked about industrial waste, as you like, that's kind of upstream and all over the place. And while e-waste can be part of that industrial waste, it looks like we, ordinary folks in our everyday lives, they'll have I want to say a bigger impact, but we don't make it, but we use it, but we demand it. I don't reckon that they would be making so much of it if we didn't demand it and use it, would we? So that's interesting about not so much where fault lies, but where the ability to impact lies. Go ahead, Jim.
Yeah, there's a reason there's so much electronic waste. We are loving these things. They're toys, they're tools. Electronics are transforming the world and our communication systems, and we can learn everything on the internet now. Things have changed so massively just in my lifetime, and it's because of electronics. But one of the downsides is, oh my God, we have all this hardware, and it's really difficult to separate all the bits of it and to isolate it and to recycle it. Really hard to reuse it, especially when the manufacturers glue everything together and make it really hard to repair. So we've really got to think about design issues. It all comes down to how we design the things we need in society. And hopefully these electronics, we are designing them because we do use them. They're not frivolous products.
So how would you categorize or tell us the different types of e-waste?
Well, e-waste is broadly defined as anything that is end of life or obsolete or somebody wants to get rid of, something that it has an electronic current or needs to have that to work, or stores electricity like batteries, transmits electricity like wires, etc. All of that is considered e-waste. Okay. And again, we produce it. All of us that have phones and laptops that we're working with right at this moment are producing it, and we've all had this problem of what to do with my own personal e-waste. So it's a very personal issue. Industrial waste is much more hidden. Very often, we don't have those eco-labels to remind us what is produced at the industrial level. But once an electronic product is made, it's something in our hands, and it becomes a decision in our lives of what to do with it. And we found at BAN that there's a lot of really bad things that happen to e-waste if you're not careful, even if you say, I'm going to recycle it. There's a lot of folks that don't recycle things properly, and they're products that are very difficult to properly recycle. So the quick and easy thing is to throw it on a ship and export it to developing countries where they use really crude techniques to try to get some value out of it. That's what's been happening for so many years now. We discovered it in China way back in 2001. And ever since then, this has been a real concern of ours, the environmental injustice of just shipping off this toxic waste to developing countries where it's managed very poorly.
How have things changed, or what have you seen? What differences, good, bad, or otherwise, have you seen since BAN has been working on this?
Yeah, so the export issue, we've worked on it for almost 2 decades now, and it's improved dramatically, I would say. It hasn't completely resolved itself because the United States, for one country, is not part of the international treaty, the Basel Convention, which aims to control the export of hazardous waste. But when I first started this work, we couldn't find any so-called recycler that wasn't exporting the things that they couldn't really deal with. They were all involved in export, throwing things on ships and shipping it off, primarily to China at the time. And we conservatively said, well, in our first reporting on this, that 80% was going offshore, even though we couldn't find anybody that wasn't exporting. But now it's more like 25 to 30%. And the reason we know this is not so much from trade data, which is very flawed and is misused, but by putting GPS trackers into electronic waste recycling streams, we have been able to follow it and extrapolate what percentages are being exported. And right now, it looks like about 25 to 35%.
Okay, down from 80.
Yeah, that's what we believe. There's no good hard data, so we rely a lot on this kind of sampling that we do. But it is very interesting to check with GPS trackers. They don't lie. They tell you exactly where they're going and where they end up.
But that's a good thing. Even if you don't know precisely or you know there's some wiggle room, that's a big number downward.
Yeah, we're very happy about that. We haven't completely eliminated it. We're still seeing things flying offshore to countries like, not so much China anymore. China's gotten very strict, but Pakistan, India, Southeast Asian countries like Malaysia and Indonesia, they're getting a lot of our e-waste.
And we just have 1 minute to go before we go to break. One of the problems we deal with all the time here is to get people to understand that as a world, we're so interconnected and have them understand why they must care.
If you don't care about other people, that's a character flaw, but I know those people exist. But believe that stuff comes back to haunt us. What was going on in China, they were burning a lot of this waste, and it would go up in smoke into the upper atmosphere and come falling down in our environment. So lead, mercury, etc., were falling out all over the earth. So
it wasn't just falling out only over China, huh?
No. The upper atmosphere, long-range transport of air pollution is a documented thing.
Right.
And it can come back and bite you. So what comes around goes around in the environment.
And with climate change, that sort of thing seems to be happening more and more often. I know just over this past summer, we had 2 or 3 sightings of the African red dust or something here in North Texas. And those are very vivid reminders of how
what
far
goes up must come down
and how it travels. We're going to go to break right now. We'll be right back on the other side with Dr. Grishma Gadekota from Cornell University and with Jim Puckett with the Basel Action Network. Thank you all. Welcome back to Healthy Living, Healthy Planet Radio today, to our show on industrial waste and e-waste, ever proliferating, hidden in sight, yet not unnoticed by our body's health. And we are back with 2 experts who are making us smarter about this. We have Jim Puckett with the Basel Action Network and Dr. Grishma Gadekota from Cornell University. Jim, before the break, you were telling us about why everybody should care, needs to care, that a lot of the issues around e-waste are being shipped off to, unfortunately, our third world countries. And with that, I want to talk about how that impacts us here in the U.S.
Yeah. Well, as I mentioned, the substandard kind of recycling processes that are used overseas involve combustion. And burning wires is very common to try to get the metals out and liberate them from the plastic housings of the wires. Same with circuit boards, et cetera, et cetera. So all this shipping of e-waste to developing countries, so-called for recycling, so-called to benefit the developing world, is not only harming them with acute and chronic toxicity, occupational disease, et cetera, but the long-range transport of these pollutants finds them going up into the upper atmosphere and raining down on all continents. And actually, China to North America is a very direct route. And they come down, they rain down, and we have lead pollution, mercury pollution in our lakes and streams because of it. So it does come around. Of course, we shouldn't be harming people in any way, shape, or form. We're all one human species. We all have children and parents and et cetera, loved ones, and we should not be putting toxics out there in the environment to be harming people or animals and plants. So it is a serious issue. The electronic waste issue is an issue of toxicity. There's heavy metals, there's organic pollutants in there, there's even some rare earth metals that of unknown toxicity, and we just throw these things into our products and then hope for the best. But what we have on planet Earth right now is when things reach the end of their life in developed countries, a lot of times they find ways to ship those off to developing countries. So we have a massive migration of this waste from north to south and from west to east on the planet. And it's really a serious problem.
It's interesting, too, because what we are all living through right now, the residuals of, is something coming from there to here. We're so accustomed to going from here to there. But I think, in my mind, one of the reasons for the significance of the pandemic and the things that we're learning from it and the things that surround it is it's coming the other way for a change. But it also shows us that we are globally interconnected.
Yeah. No, the supply chain, it's very interesting to look at electronics in specific terms and look at the whole life cycle. And you will find that the dirtiest, highly polluting parts of the life cycle take place in the developing world. So they have a disproportionate burden. The actual extraction of the metals, et cetera, very harmful to the environment. The manufacturing is very harmful to the workers in the environment. We get it as a product. It sits on our lap as a laptop. We get a tiny bit of emissions, off-gassing from the plastics, perhaps. But then at the end of life, we send it back to the developing world where it's, again, a very harmful potential problem. So they get a real disproportionate burden, and we're not thinking about that at all.
Indeed. Jim, what would you say are the biggest contributors to e-waste?
Well, I think the biggest problem is always that we don't design the products to not become waste. We design things for the dump, unfortunately. They design things for single use, quick use, and then nobody cares. And the manufacturers are largely to blame. We're to blame for not holding them more accountable in terms of design for the environment. So things should be designed for a long life. They should be designed toxic-free. They should be designed to be repairable. And that's extremely important, including giving open source to the repair manuals and the parts, etc. And then, of course, if it can't be reused, they need to design things to be properly recycled. And there's so many examples of how that has never happened, really. From our old cathode ray tube TVs, they never thought about how they were going to recycle those when they died. The flat screen TVs where we can't remove the LED lights easily, we can't remove the mercury easily. Nothing is easily recyclable in the electronic world. And there's very few exceptions. There's a phone that's made in Europe called the Fairphone, where they make it modular and it can be easily updated and upgraded, and will have a very long life ahead of it. Those are unfortunately not for sale in the U.S., but there's unfortunately very few examples of proper green design so that we can avoid making waste in the first instance.
Indeed. Now, in terms of components of the e-waste, there's some metals in there. What would you say are perhaps the most dangerous to health and then the most dangerous to environment?
Yeah, there's three categories, but two of them are most of concern probably. And that's the heavy metals. So in our electronics, we're still using a lot of lead, mercury, cadmium. Those are still in there. They haven't been banned or phased out. There's been reductions in lead over time driven by the European Union and their legislation. But we still have a lot of heavy metals, and they last forever. You cannot destroy a heavy metal. So it's all, as soon as you pull it out of the ground, it's almost a waste to be thought of that way. And then we have the organics. So we put a lot of organic compounds into plastics and into the circuit boards, et cetera, like brominated flame retardants, which have very high toxicity, and they bioaccumulate in your bodies and in the environment, and they also last a very, very long time. They're not immortal, but they last an extremely long time, and they move up the food chain, get into our fatty tissue, and cause disease, endocrine disruption, cancers, birth defects, etc. So these are the concerns, and there's rare earth metals that are in there increasingly. But unfortunately, you look at the toxicity data, and nobody really knows how toxic a lot of these rare earth metals are, but we still use them, which is pretty outrageous when you think about it. We're using things, and we're all white rats in a laboratory, and they find out later, ooh, that was toxic, too bad.
Like lead and mercury, it seems to take forever and something beyond overwhelming body of evidence.
Yeah, we've had those metals for as long as human beings have been around. They've been using lead and mercury, and yeah, we know the toxicity of those. There's no excuse to continue to put those into products. We have so much ability to use alternatives now. And sometimes the alternatives are more costly in the short run because they're not counting the externalized costs of the long run and the hidden costs to other people. Yeah.
Grishma, what would you say are the most harmful or most impactful industrial waste streams for the environment and then for human health?
So, Bernice, thank you so much. The answer to that question would be depending on who you ask. But given the world that we live in right now, and my own prejudice, if you will, around climate and greenhouse gas emissions, I would say it is greenhouse gas emissions at this point in time. And the reason I say that is because we have technologies to handle wastewater emissions. We have technologies to some degree handle solid waste residues, to some degree. It's not all salts, but worst case scenario, we can put it into a landfill. Again, I'm not advocating for it. Right. That's one solution that's been practiced. But greenhouse gas emissions into the atmosphere, unabated, is really harmful in the long run. And I think it's harmful at many different levels. The first is that getting accountability is a challenge, right? As Jim was saying, we can emit a lot of things. Even if it gets emitted out of China, those emissions could just fall back onto Earth in a different part of the world. The detrimental impacts of climate are felt disproportionately, and we don't know who's going to be impacted next. And that's the scary part. We don't know how it's going to get manifested. We don't know if it's going to get manifested in the form of flood. We don't know if it's going to manifest in the form of a heat wave, in the form of drought, in the form of soil degradation in some part of the world. There's so many uncertainties associated with that. So for me, unabated greenhouse gas emissions, not having inadequate technologies or approaches. We don't necessarily need to have technologies. We can have practices. We can have agricultural practices, for example. We can have household practices, for example, on how we manage our living around greenhouse gas emissions. A lot of awareness needs to be brought into that space. So I would say, given the times that we are living in right now, those are the emissions that really demand a lot of our attention at this point in time.
Indeed. We have 1 minute to go before break, and I'm going to stay with you, Grishma. Do we have any history in the past how industrial waste have maybe created large-scale disease cycles or anything? I say that because people can get that like we are with the COVID pandemic. And I don't know if that's happened or not, but the industrial waste are so prevalent in that they affect our soil, our water, our air. And so that just made me begin to wonder, has any of that ever caused a disease cycle yet that we know of?
So mercury is a great example there, right? So when mercury gets emitted into our water resources, we know that it makes its way into the food chain. It gets bioamplified or magnified. It makes its way into women's bodies and particularly pregnant women who've consumed fish in certain parts of the world, particularly in Eastern Asia, I think Japan, if I'm not mistaken, they've seen very detrimental impacts because of mercury-based contamination. It's very, very well documented.
Indeed, and I imagine there's more of that to come. We're going to go to break now. We have been with Dr. Grishma Gadekota and Jim Puckett, and we will be back right on the other side of the break for them to continue to help us unpack and understand these issues around industrial waste and e-waste. Thank you all. I want to give a shout out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Magazine, the Green, Healthy, and Sustainable Living Authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in all Whole Foods markets, natural grocers, central markets, sunflower shops, and many, many other locations, as well as available free for download online at nadallas.com. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsor is Lynn Dental Care, practicing dentistry for over 38 years with a holistic approach, non-mercury, looking at the whole body. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsors. Welcome back to Healthy Living, Healthy Planet Radio today, to our show on industrial waste and e-waste. Ever proliferating, hidden in plain sight, yet not going unnoticed by our body's health. And we are back with Dr. Grishma Gadekota at Cornell University and Jim Puckett with the Basel Action Network. And they really are making us smarter about all of this. Grishma, I know that last year the Department of Energy made a grant to Cornell University to explore the reuse of industrial waste. Can you tell us more about this project, as well as what was the goal, what did you want to achieve, and then why is our country, through the DOE, investing in this area of study?
Bernice, thank you so much for that question. So this particular grant was made to come up with ways to manage iron and steel making solid residues and CO2 emissions at the same time. So typically when we think about industrial waste management, we think about just treating the solid emission alone, or just the gaseous emission alone, or the wastewater emissions alone, because each of those emissions get regulated by a different, I would say, entity, even if it is within one regulatory body. But now I think there's a rising awareness that there are a lot of co-produced resources that one could label as being potentially waste, that we can actually use them together and make them less environmentally polluting. So it's really that awareness, I think, within DOE that helped us win this grant. And getting into the science of it, when we make iron and steel, in addition to the CO2 emission, there's a lot of solid emission that comes along too. And when I say solid emission, they produce a material which is known as slag. And in addition to that, there's other metal-bearing wastes, and these wastes are known as sludge, and some of these are also known as dust.
When they do this out into our atmosphere and all around us, and our environment is going stuff in the air, and then the sludge, I guess, can go either in the ground or the water or both?
Yes, so the CO2 emission goes into the air, right? Because right now we don't have a price on emitting CO2. We don't really have a documented social cost of carbon, cost of emitting CO2. That's really not a very active area of conversation for us, at least hasn't been for the past decade or so. Now it's slowly coming back into the way people think about CO2 and the social impacts of CO2. But then when we look at the solid emission piece of it, you're absolutely right. I mean, solids can be landfilled or they can be reused in some form or the other. The problem is that some of these have a lot of heavy metal waste. Some of them have a lot of chromium, nickel, lead, for example. And we're interested in being able to treat these residues. We're interested in being able to recover these metals because we realize that these metals do have value, right? So instead of going and mining an ore to recover these metals, why don't we try to recover the metals from these residues, right? And why don't we use CO2 to do that? And so we're coming up with new chemical pathways. We're coming up with new technologies in this space that will help us recover metals more effectively from these resources, that will also help us capture CO2, even if it's a small fraction of that CO2, and help recycle some of those CO2 emissions back into the manufacturing process.
Indeed. And I want to go back to something Jim was talking about earlier that's related to this, and to talk about and compare the value components of e-waste and their benefits. We know there's toxic components and other detriments too, but there's got to be some economics there, and I want us to understand that in terms of the value and the components of e-waste, but also on a whole, but from the macro level. Jim?
Yeah, well, absolutely. E-waste, has value. People think about copper and the gold in there, obviously, but there's a lot of value, and even in plastics sometimes, and aluminum and steel certainly. So recycling is large part about that, and we are actually losing some of the elements on the planet, and they're diffusing all over the place, and then getting harder and harder to find in the crust of the earth to mine. So we really are talking about urban ore, that we need to think about this as urban ore and to reuse it. But it is true also that more and more e-waste is not so inherently valuable, and we have to think about the entire recycling of e-waste as a service, and a service of not producing the waste to begin with. Because, again, it's just, if you have toxicity taken aside, it's still just this massive littering problem on our planet. So we have to think of recycling more and more as a service that we're willing to pay for. And we don't expect to get paid when we hand over our old equipment, that indeed it's going to cost us to properly manage this material.
Indeed. Now, back in the day, they used to pay people for turning in their bottles, like soda bottles and glass.
Right.
Did we have any learnings on our experience from there that we might be able to use?
Well, let's hope so. I mean, that was kind of a brilliant economic system, and I miss the days when we had glass bottles, and now we're stuck with plastic bottles which have their own toxicity. You talked about that before. But, yeah, there's some basic, very common things we can think about, like having a lease-based economy. Rather than owning all your electronic equipment, if you were to lease it, then the manufacturers would be the leasors, and they would have a built-in incentive to to design these things in a green way, because they're stuck with the waste at the end of life. They're stuck with the liabilities, the toxicity, what have you. So if you put the onus back on the manufacturer as the leasor, that they own the equipment always, and we don't, there's a built-in economic incentive, even in a capitalist system, to design things in a green way, design things for long life without toxics, etc. And that really is the answer. Before we leave this program, I want to talk also about what you as a consumer can do once you're stuck with e-waste, because we are all stuck with it.
I got a stack of computers in my closet. Like, okay, what's the best thing to do with them?
Well, that's the first thing. That's the first thing on my list. Is pull the things out of your closet and your drawer, because they're losing value, and that value I'm talking about that they're losing is the reuse value. So the older they get, you're not likely to have anybody interested in reusing them. So the second thing you do after you pull them out of there is if you don't want to fix it yourself, and there's a great website if you're not intimidated to try to fix things yourself, it's called iFixit, and it's not as hard as you think sometimes to repair these things. So I would go to the website iFixit. But if you are wanting to not fix it yourself, find a recycler refurbisher that's certified. We have a certified program called eStewards, and this is a certification that doesn't allow export of hazardous materials to developing countries. takes care of all the data that's in there, so you're not going to lose your private data, and photographs are going to be destroyed. Nobody's going to pick those up and take your identity, et cetera. So there's a whole list of comprehensive elements of responsibility that a proper certified recycler or refurbisher will follow. And we highly recommend our program, eSteward.
Indeed. Thank you for telling us about that. Grishma, if you could talk to our listeners a little bit about perhaps some unknown or some overlooked effects of industrial waste that they may not be aware of that's all around us.
The residues of industrial waste are everywhere. Metals getting into our soil resources, metals getting into our water resources. That's another big concern. My personal problem, the problem that I work on quite extensively is that of greenhouse gas emissions and methane emissions. Mm-hmm. And so if you're a farmer and if you have nitrogen-based emissions coming out of your farm, unfortunately, you're contributing to greenhouse gas emissions. So it's important to think about agricultural or cropping practices that will help abate that. If you're in industry, if you're working for an industry, and if you're emitting CO2 or methane, it's important to start thinking about putting in technologies, I would say, to help abate that. I mean, it's just not for our own good, but it's for the good of the planet.
What advice can you give ordinary people in their everyday lives? What can they do to help drive solutions to this industrial waste issue?
So there is the technology perspective, and then there is the perspective of how we as people accept these approaches, right? One way to think about the space is to think about it, is to approach it from the perspective of acceptance. What I mean by that is we need a portfolio of technologies. We need wide range of solutions. Some cases, the solutions can apply for small-scale businesses. Some solutions can be scaled up quite easily. We have to be embracing all of them. We have to be accepting of all of them. This is not the time to be judgmental about treating water emission is better than treating greenhouse gas emission, or treating electronic waste is better than treating industrial waste. I think the view that we want to take to this is that all of these emissions have to be looked at very, very carefully, have to be looked at with intention. It's not just humanity that is impacted, it's also the entire ecosystem that is impacted by these emissions.
Indeed, and that affects them as individuals, and we are going to need to leave now. We're at the end of our time, but that is what we try to do here on Healthy Living, Healthy Planet Radio, is to educate people about what's going on around them so they know. And once they know how it affects them and how it's affecting all that is around them, then we see that people move to action. But thank you all so much for helping us to unpack and understand this some more, and we hope that you will join us again, if not later this season, on some other of our topics, and next year again, as we talk about this. So we have been with Dr. Grishma Gadekota from Cornell University, and we have been with Jim Puckett with the Basel Action Network, and they indeed have made us smarter today. Thank you all for being with us today.
Thank you,
Thanks for having us.
Okay. And thank you, listeners, for listening in today to Healthy Living, Healthy Planet Radio. The conversation starts here, but our goal is for it to continue in your home, in your social circles, your workplaces, at the water cooler, and in the grocery checkout line, so that we can all work together to realize that healthy living is simply not possible without a healthy planet. Our culture is a result of 1 trillion tiny acts taken by billions of people every day, like yourself. And each of those tiny acts can seem insignificant, but all of them add up, one way or the other, to the change that we each live through. This is your host, Bernice Butler. Thank you for listening today, and join us again next week for our last show for the month on waste and waste management and waste generation. And be sure to listen to any of our past shows wherever you get your podcast. Thank you.